Hello, everybody. Welcome back to Concordium series for workshop number 5 this week. We're joined again by Dragos, and we're going to be hearing about an introduction to sponsored transactions. So this is going to be an explanation of how they work and why they're key to enabling adoption and usability of protocol level tokens. This is workshop number 5 out of 7. We've got 2 more after this. I think Dragos is going to join us for one of them, and then a couple of the other members of the team will be taking over the last one. Thank you guys for joining and for turning up again. It goes very well towards your certification and graduation at the end of this program. So keep turning up, and we'll get that certificate over to you at the end of it. So I will hand over to Dragos now, who will kick things off.
Hello everyone, thanks for the introduction, Giles. So today we will be discussing sponsored transactions and how this tie into everything we've discussed so far with the protocol. What we're going to be covering, first of all, we'll do a bit of a recap. We're going to go through identity, verify and access, and protocol level tokens. So basically everything that we've discussed in the previous workshops. Then we'll do a deep dive in sponsored transactions. We'll talk about the dual token problem. We will explain how sponsored transactions work at the protocol level. We'll be showing the full signing flow. And at the end, the sponsor service with a live demo. Finally, we'll be talking about the full stack in action. So I will be showing some use cases idea and verify and pay with sponsorship. Now let's start with the recap. So protocol level identity. The main gist of everything we've discussed is that on Concordium, identity is not optional and is not an add-on. It's built into the protocol from the account creation step. This means that every account is tied to a verified real-world identity. At the same time, there is no personal data ever stored on chain. And this is done through separation of powers. So we have the 3 actors that we mentioned before. We have the identity providers, the privacy guardians, and the authority. The goal of these is that in the end, no single party will be able to link an identity to an account alone. There are also 4 zero-knowledge proofs with proof types, which stand at the base of everything. So we have reveal attribute, attribute in range, attribute in set, and attribute not in set. These can be used respectively for many different use cases. All right. Next up, we have discussed verify and access. So this is the actual implementation of the protocol level identity. And the goal is to have compliance without any data liability. So it's a 3-party model. On the one side, we have the user. In the middle, we're going to have the merchant. And it will all be done through the Concordium blockchain. The way it works is quite simple. You can just be able to prove an attribute via zero-knowledge proofs. So you can say something like, I am over 18 or I am an EU resident without actually sharing any of your data. Something quite important about this is that 3 on-chain anchors will create an immutable audit trail. And as a bonus for the merchant will already receive a cryptographic proof result, no personal data, so there's no risk on that side. It will only be basically verified or not verified. Finality, as for every transaction on Concordium, is 4 seconds. And the cost for anchors is around 2 cents, as this is a special type of transaction. All right. Next up, protocol level tokens, PLTs. So this was last week's workshop. These are Concordium's implementation of stablecoins. They are tokens issued and managed natively at the protocol level, not via smart contracts. They were introduced in 2025 through Protocol 9. You can read everything about the structure in the CI7 specification. The core operations are mint, burn, transfer, allow list, and deny list. It's very important that PLTs provide self-custody, so tokens are always in the user's wallet, not locked in any smart contract. then fails, there will all be it will all be rejected, the entire operation. The full ecosystem at the moment is we have 10 stable coins in 5 currencies from 3 regulated issuers. So we have Stabler, Arise, and VNX. These are all live on mainnet. Now, having said all these, there is still one friction point left. So we now have identity verified at the protocol level. We have privacy presenting verification for merchants and compliant stable coins as protocol level tokens, so we can do verify and pay actually. But there is still a problem. A user holding stable coins will also need to hold CCDs in order to pay the transaction fees. Now, the thing is, for somebody who will just want to pay using stablecoins, having to acquire a second token first is at best confusing and at worst an actual blocker. And in full, it's bad user experience. Now, the solution to this was introduced in Protocol 10 and its sponsored transactions. Let's go ahead. What we have at the basis of this is the dual token problem. So on most blockchain, using a token requires holding the native currency for gas fees. It was the same on Concordium before Protocol 10. So if a user has 50 euro stable coins, they want to pay a merchant, the transaction will require holding CCDs for the fee. If the user doesn't have any CCDs, the transaction will fail. This is very bad user experience because the goal is to have everything frictionless. So best case scenario would be somebody not even knowing that they used blockchain for this. Just you're holding stable coins, you go to a website and you just pay and that's it. One click and it's all done. This is blocking real-world adoption. So first of all, regular users do not understand gas tokens and gas fees and everything that has to do with that. And that's fine because they don't have to. The goal is just to have a better experience than what's currently available. And merchants can't just ask customers to go buy CCDs first before paying for something or before buying a product or a service. So this breaks the payment experience, especially for anyone coming from a Web2 background. Now, the goal is that with sponsored transactions, the user will only be holding 50 euros, then the sponsor will be paying the CCD fees, and the fee will be just 1 cent. So the goal of this is to be scalable. As I've said, these were introduced in Protocol 10, deployed in March. It means that a third party will pay the CCD transaction fee on behalf of the sender. The user will only sign for what they care about, the PLT payments. So you will see in the live demo that we'll be doing towards the end that what you see as a user is basically the same as before. So, and it all happens in the background. Something quite important is that this also works at the protocol level. So it's not a smart contract workaround. And it also applies to all transaction types, PLT operations, smart contract calls, and everything else. Any new transaction type added to the chain will also automatically support sponsored transactions. Now, let's talk a bit about the signing flow. So 2 signatures will be required. The sender will have to sign the transaction payload. As a sender, you're basically saying, I authorize transferring 50 EUR to this merchant, 50 stablecoins. The second part of this is that the sponsor will sign to cover the fee. So the sponsor will agree to pay the CCD for the costs of this transaction, which will be just 1 cent. Both signatures must be present before the transaction is submitted to chain. This means in the end that the sender will authorize the action and the sponsor will pay for the fee. These will be kept as separate concerns for you as a merchant or an app developer, or if you're building a product and integrating Concordium. When the transaction is finalized, the sender's sequence number will be incremented. We'll discuss sequence numbers a bit more later in the workshop. Now, let's have a look at a sequence diagram for how all of this works. So it's important to remember the user will receive step 6. So basically signing the transaction, a wallet pop-up for review. how does this work? So we have the user's wallet. First of all, you go to any application, you just connect to the front end. Then a transfer will be submitted, a recipient will be specified, an amount and a token ID for what you're using to pay. This all goes into the front end of a merchant's dApp, for example. Then a post request can be done to an endpoint in the sponsor's backend. It will include the sender, the recipient, the amount, the token ID, and the number of decimals for that specific token. Then in the backend, there will be a call down to the actual chain itself. It will get the next account nonce. So this is the sequence number that I mentioned before. The transaction will be built only at this point by the backend. The sponsor will be added, and the sponsor will sign using the key. And then the front end will receive as JSON a sponsored transaction. This all will be going back to the wallet, and the user will have to authorize it or decline it. Only at the end, a signed transaction is actually submitted to the Concordium chain. A fee will only be deducted from the sponsor's account. And the last step that happens in the background is that the transaction hash will be returned to the front end, so you as a user can verify that the transaction went through successfully. Now, let's talk a bit about the transaction structure. So a sponsored transaction uses version 2 account transaction, which has been introduced in Protocol 10. There are 3 components in this. So we have the sender. This is the account initiating the action. The sponsor, the account paying the CCD fee. And then the payload, this is the actual operation itself. This can be everything, a PLT transfer, even a CCD transfer, a contract call, or even a batch of operations. The goal of the version 2 format when it was designed was to have extensibility in mind. So the header structure will allow all future protocol updates to be added without restructuring the transaction format. So this will lead to backwards compatibility. Now, as a basic example of this, we have just Bob going to buy some wine from a merchant online. So the way it works is that Bob as a user will be holding stablecoins, will have 0 CCDs, and then we'll sign a transfer for 50 euros. This will go through to the wine merchant. Here, the sponsor will pay the CCD fees. This will only be 1 cent per transaction. The merchant will actually have to run the sponsor service on the backend or use one that is run by other providers. And the final on-chain result is that Bob as a user will only interact with your OR. He doesn't even need to know that that CCD exists. He can only care about the actual stablecoins and finalizing the transaction as quick as possible. And the merchant will observe the CCD fee. So you can think about this just how Visa or any other card networks charge the merchant, not the buyer. Now, who can sponsor? So anyone with a Concordium account and sufficient balance can become a sponsor. A very useful use case will be merchants. So merchants would cover the fee for customers. Stablecoin issuers, they could cover the fees for users transacting with the token. This could be used as a growth incentive for the stablecoin. There could even be so-called gas stations. So this would be, you could be running a dedicated service that would sponsor the transaction for a fee, and this would be paid in PLTs or off-chain. And there could be also dApp operators. So they could cover the fee from the users to remove any onboarding friction. If you want your goal, if you're running a dApp, is to acquire users as fast as possible. So the onboarding process should be very fast and seamless. And enterprises could use it, for example, to sponsor employee transaction costs through any internal systems. Now, the fee cost for this is 1 cent per transaction. So this is very important because the goal is that sponsoring at scale is practical. if you have thousands of users, this will still be single-digit numbers. All right, regarding what can be sponsored, this is basically everything we've discussed so far. So PLT transfers, allow list and deny list operations, smart contract deployment, initializations or updates, or automized PLT operations, so doing more operations in one transaction, that could also be sponsored. And any future transaction type will be sponsorable by default. Now, before I've mentioned the sequence number. So what is this exactly? If you've interacted with other chains before, just from cryptography in general, you might know about a nonce. So basically every account on Concordium has a sequence number that's associated to it. This is a counter that goes up by 1 with every transaction that is being sent from that account. So it basically keeps count of the number of transactions. Now, the way it works, when an account sends a transaction, the application that's sending it must include the next expected sequence number. If the number doesn't match whatever the chain expects, the transaction will be rejected. The goal of this is to prevent replay attacks. So this means that nobody sitting in the middle between a dApp and the chain itself can resubmit an old transaction because the sequence number has already been used. And it also guarantees the order. So it means that transactions being done from the same account are always processed in the intended order. So you could actually check which transaction was first. And as a developer, this is just managed automatically via simple methods. So you don't need to calculate this or anything like it. You can just use the Web SDK to get it. All right. How this works with sponsored transactions. So in a sponsored transaction, only the sender sequence number is consumed, not the sponsors. So let's do the example of Alice and a merchant. Alice as a sender will have a sequence number of 5, let's say. The merchant will have one of 100. If Alice will be sending a sponsored PLT transfer, after finalization, the sequence number will increase to 6, while the merchants will still be 100. If the merchant later does any other separate transactions, only then the sequence number will increase to 101. This means that the sender will control the ordering of their own transactions, and the sponsor's own transaction flow is not affected by sponsoring any other accounts. So if you want to be a sponsor, but it matters for you for any reason, the order of the transactions, it will not affect you. And also a merchant that will be sponsoring thousands of customer transactions will not create sequencing conflicts with the merchant's own operations. So this all could be kept separate. Now, let's talk about some edge cases. What happens if something goes wrong? If a very simple case would be the sponsor doesn't have enough CCDs, then the transaction will simply be rejected before inclusion in the next block. There will be no state changes and no stable coins moved. If there is an invalid signature, either from the sender or the sponsor, the transaction will be automatically rejected. If the transaction expires before inclusion, so when you send a transaction, you can attach an expiry time if you want to prevent replay attacks, or if you just want to be sure that the app will actually send the transaction quite soon. If that expiry time passes, then the transaction is dropped and the sequence number is not changed at all. If the sequence number is wrong, the transaction will simply not be eligible for inclusion. It will simply be ignored by the chain itself. If the sponsor goes offline, this will only affect new transactions, but the ones that were already submitted are actually unaffected. Fee costs, as we've mentioned before, is just 1 cent and pegged to the euro. Now we'll actually have a look at the dApp that's using a sponsor service, and let's discuss the architecture a little bit before that. So what we have on here will be just a very simple sponsor backend. And the front end will be doing a post request to the backend. The backend will actually contain the wallet and the transaction builder. And this one will, and the actual key itself, which is private, will only be in the backend. This will be loaded at startup and never sent to the front end itself. We'll discuss security implications further on. The backend will be the one that's communicating with the Concordium node. And the flow is basically that the front end does a post requests. The backend will fetch a nonce, which is the sequence number. The backend will build and sign the transaction. Then it will be returned to the actual front end as in a JSON format. And at the end, the front end will communicate with the wallet and the wallet will co-sign. Step 5, this part here is the only user interaction. The user will have a pop-up and to review and approve. I noticed a question in the chat. So it's, is the counter incremented for invalid signatures or lack of CCD funds? No, that's the useful and important part of the counter. The counter will only be incremented for successful transactions. So if the signature is invalid or if there's a lack of funds, the counter will remain the same and the transaction will simply be rejected. If you want to have a look at this, at how this actually works in the backend, you as a developer will only see transaction.sponsor, but you can have a look in the Concordium Web SDK, any version above 12 to actually see how it was implemented, since this is all open source. Now, let's have a look at some actual sample code. So in the backend, the way you would build a transaction, it's just literally one line of code. So you will do a transaction. The type is going to be, in this case, let's say token update. You will specify the token ID and the list of operations that you want to do. Metadata will be added on top. So the sender, the nonce, which represent the sequence number and the expiry time. And at the end, a sponsor will be added. The sponsor's account will be specified. This will be done, of course, only if you have the private key of the sponsor account, and the entire transaction will be built. This will basically produce a transaction that will have the sponsor's address, so a payload, but it won't be signed yet. Then this bit, transaction.sponsor, will actually add the sponsor's cryptographic signature. At the end, you can do transaction.toJSON to serialize it for transport to the front end. If you want to have a look at a tutorial, you can scan this QR code on the right, and I will give you 15 to 30 seconds if anyone is curious to have a look. We'll go over the tutorial a bit anyways in the end. All right, let's move on and have a look at the actual front end next. So there's a question why sponsored address is not signed in this phase. Well, the thing is that the sponsored address will only be signed in the user's wallet. So when you send it to the backend, it won't be signed until it comes back to your wallet, and it will only be signed when you as a user will click approve. All right, now let's have a look at some front-end code. This is even simpler. So the front end will receive the sponsor signed JSON and then pass it on to the wallet. The way you do this is you use a method called detect Concordium provider. A parse transaction will then be built. This will be transaction. It will be signable from JSON, and from the backend, before when you call it, you will receive a sponsored transaction. So this is the JSON package that we discussed in the previous slide. And then at the end, you will be able to get the transaction hash, and this bit here, provider that sends sponsor transaction, will actually send the transaction to the wallet to be approved and authorized by the user, and then it will be sent to the chain itself. So this bit at the end will open the wallet pop-up where the user will review the transaction. The user won't see any CCD or gas fee. It will be called a free transaction. And when the user approves, only then the wallet will add the sender signature and submit to the chain. This is the same QR code for the same tutorial, but it's for the frontend code this time instead of the backend. Now, I'll also give you 30 seconds to a minute if you want to have a look at the GitHub repository. So this is Concordium dApp examples. So the full code for this is open source, and then we're going to go through a live demo. All right. Now, before we move on to the live demo, the QR code that you scanned before, that's just an example application that you could use to build your own app, but it's not a production level app, a production ready app by no means. So if you want to actually do something in production, you should keep a few security considerations in mind. So what's important, first of all, is that the sponsor service is a trust point. So that decides which transaction to sponsor, which means that it should have its own business logic for what it will and it won't sponsor. So you should always keep the sponsor private key on the backend only. Preferably, you should even use a KMS, so that's a key management system, or even a hardware security module for the key management in production. You should never use a plain text wallet file. The key itself should never be exposed to the front end. Rate limiting should be implemented in any backend to prevent abuse of endpoints. And all incoming transaction requests should be validated before sponsoring. So just simple checks like checking the recipient, the amount, and the token. Also, reasonable expiry times should be set on transactions. So 5 minutes would be a typical expiry time. If the client doesn't respond in 5 minutes, usually means that something is wrong and the transaction will simply be canceled. And finally, if you're going to be building a backend, it should always monitor the sponsor wallet balance and then set up alerts for low funds in order to avoid any failed transactions. All right, and now let's do a bit of a live demo. So what we have in here is the app that I've mentioned before. So this is the repository I mentioned. It's quite a simple project, so it's just a Docker Compose file to host it, a front end with its own Docker file and a script, then just a constant file and just a simple index, and then in the backend, it's the wallet itself and the Docker file and just one piece of business logic, which this will all be explained in the tutorial. But if you want to run it yourself, you have a tutorial in here. You can just create a .env file and set up all of these variables. You can connect to the Concordium testnet node or even to the local stack that we showed in the previous workshops. Now let's have a look at the dApp itself actually. So as you can see, I just connected the browser wallet. Now what's quite interesting about this is I have 98 PLTs in here, but I have no CCD. So let's try sending a transaction. A normal one would fail, the wallet wouldn't even let me. But I can just copy this account address on here. And now let's send one PLT, let's say. Now, as you can see, the transaction fee for this is a free transaction, and even the transaction cost is mentioned here, the address that is actually covering it. And if I just approve this, this will take around 4 seconds. It's already done. And now we can even have a look at the transaction hash itself. Before that, if we look in here, we can see that the amount changed. This account now has 97 PLTs. There was no CCDs deducted. And the actual sponsor is this account, which, as you can see, around 9 CCDs was deducted. And this is the account that actually received the PLTs. And as with any transaction, we can go to CCD scan. This is the official Explorer. We're set on testnet, and you can actually see the transaction age 1 minute, and it was a sponsored transfer. This was set in the memo by the app. In a real case scenario, for example, you could have the link to a website here or actually a confirmation. And the transfer of one EU demo was done from this account to the other one in the wallet. All right, now if you want to have a look at the application, it's all in this repository here. And also I would suggest to have a look at all the other dApp examples in here. So some of these are quite new, others are a bit older, but they're all still working, and it's quite easy to just copy paste them if you want to start building your own dApps. Just clone the repo and that's it. All right, now let's move on. So let's now discuss the full stack in action, what we've covered in all of the past 5 workshops so far. The full PayFi stack. So we have Verify and Pay on top with sponsorship now. This will include zero-knowledge identity proofs, PLT stablecoin payments, and the fee will be sponsored, leading to a full flow for PayFi. This is all being done, first of all, through the identity layer, which represents the blockchain itself, through zero-knowledge proofs. Then another bit will be verify and access. That will only handle the accessing part, and protocol level tokens. Sponsored transactions introduced in P10 is the bit that ties it all together. And at the end, the full stack is completed in order to have users on board to your website, from onboarding to verifying, just accessing the website, to final payment with an auditable anchors on chain. So a full audit log on chain. Again, verify and pay with sponsorship. This is basically the same thing I mentioned before. So the way it will work, a user will only be able to hold EUR. Step 1 will be to verify an identity. This could be a separate transaction because a user might want to stop here. So you're just verifying an identity. You can prove that the user is over 18. Step 2 would be a PLT payment at this point. The sponsor will pay the transaction fee. And then as a merchant or a service provider, you would have the identity verified and the payment received without storing any personal identifiable information. The blockchain will be used to audit anchors, to have an immutable record of the PLT transfer, and the fee itself will be sponsored. The end goal is to have an experience that's as seamless as possible. Now, let's discuss a few potential use cases if you want to try building some dApps. So a simple one that you could do would be age-gated commerce. So, for example, an online shop selling age-restricted products. So let's say a wine shop, for example. So the way this would go in Web 2 without using Concordium would be a customer will create an account, upload an ID, wait a bit for a verification. The shop would actually have to store all private information about the user. This would create GDPR liability. And then the shop would have to pay for ID verification, which could even be $1.50 per check. So around that. Then the payment would be handled via card network. So that's an extra 1% somewhere between 1.5 to 3.5% in fees. And it also takes in between 1 and 3 days to actually get the payment itself. Whereas with Concordium, the customer would simply connect the wallet, prove the age via zero-knowledge proof, no GDPR liability here. It will all be paid with protocol level tokens. The merchant will sponsor the CCD fees. The settlement would be in around 4 seconds for a fee of just 1 cent. And then at the end, there will be a full-on audit trail on chain, immutable, so there would be no risk to the merchant. Another potential use case might be cross-border business-to-business settlements. So let's say that a European company will be paying a supplier in Singapore. The traditional flow, how this works at the moment, is a swift wire transfer, for example, where that takes between 1 to 5 business days. It costs between 15 to 50 euros per just one transfer. There is a correspondent banking chain with a bunch of intermediaries in the middle, and there are also fees related to currency conversion. If this were to be implemented via Concordium, though, it would mean that the buyer's identity would be verified because Know Your Business is also available. So Concordium ID is not only for regular users, but also for businesses. Payment would be done in PLTs. The company's treasury could sponsor the CCD fees. Settlement is in around 4 seconds. And at the end, there are no intermediaries and there's a full compliance audit trail that's on chain. All right. Then the next one could be an online gambling platform with jurisdiction and range restrictions. In this case, the platform would need to verify that the user is above 18 or above 21, depending on jurisdiction. The user is not in an allowed jurisdiction or not on a self-exclusion list. The way you'd implement this, you could use the 4 proof types. So you would have attribute in range proof for the age being over 18, attribute in set for the country of residence, attribute not in set in order not to be on a self-exclusion list, and this will all be verified via zero-knowledge proofs. So at the end, deposit and withdrawals could be done through the chain itself with sponsored transaction, and the platform will sponsor all the fees, and the player would only interact with stablecoins and the actual gaming platform itself. Now, this has been it for this workshop. Next week, we will discuss X402 and agentic AI payments. We have a few resources at the end. So this is basically what I've shown you before, the code for the sponsored transaction app, the tutorial, and the docs. I will leave it on this slide for a couple of seconds. All right. Now, if you will have any further questions after the workshop, we can connect on LinkedIn. You can scan that QR code for it. And at this point, if you have any other questions, please pop them over in the chat or in the Q&A section. Thanks everyone for the attention so far. I don't see any new questions. So Giles, over to you. Thank you.
Yeah, perfect. Thank you very much, Dragos, for that. I hope everyone enjoyed that, found it interesting, and you have learned something from that. That concludes workshop number 5 then, out of 7. So we've got 2 more left, 1 more next week, and the weekend after, and the week after. Yeah, as Dragos mentioned, next week is same time again, Tuesday at 5 p.m. BST. So same time for everyone again. And this is going to be looking at X402 sponsored transactions, a bit of an introduction to these things. So if you've turned up today, make sure you come again tomorrow, next week, as this all counts towards your certification at the end of it. And any questions, drop in the Discord. If you have any hard or more questions about the platform or anything like that, just send me a DM, and I can give you a hand with that. But any technical questions, send them over on the Discord, and Dragos or one of the team can get onto them. Okay, awesome. I think that concludes it all. Thank you all very much for joining, and see you all next week.
Thanks, everyone.
Bye.